So we have discussed some basic concepts in earlier video. If you have not watched that, we strongly recommend you to watch it so that you understand what we are going to discuss in this. We have discussed about a person A, person B working with their own efficient work rates, and then what will happen if they work together for A, B, C, 2 people, 3 people, right, etc. What if there are multiple people with the same work rate working? That is, let's assume there is A, there is B, and there is C. All of them can put 10 bricks per day, right? What will be their combined work rate? 10 plus 10 plus 10 are 3 people into 10 per each person. The individual work rate, that's 30 bricks per day. Right? What if I have 10 people like this? A, B, C, and so on up to whatever H or so. J, I, J, 10 people. Each of them can put 10 bricks a day. So I can simply say that 10 into 10 bricks per day, that's 100 bricks being put up in a day. Right? So this is one type where you'll get to see like 10 men completed the work in 13 days. How much time will 5 men take? Right? It's basically with an assumption that all the men individually, like let's assume there's man 1, man 2, man 3, etc., man 10, all of them have same work rate. Now that's the assumption with which we'll work. We'll solve a problem to show how we can do that. Let's solve the same example, right? So 10 men, let me assume the work rate of each man is W, right? All the 10 people put up the same work. So 10 people working will put W bricks per day or units per day. So 10 men will put 10 into W, 10 W bricks in a day. So they took 13 days to complete. What is the total work? Work rate into time. So 10 W or units are put in a day into 13 days. That's 130 W is the total work. Now how many bricks would 5 men put? 5 W in a day. I need to figure out how long they're going to take. Let's assume this to be T. The total work is 130 W. 5 men will put 5 W bricks a day, and in time T, so W will get cancelled out and this will be 26. So they will take basically 26 days. That's how we'll solve the questions. Right, let's look at an example. 50 men work together to complete the work in 100 days. How many days will it take for one man to complete the same work alone? Let's assume all the men have the same work rate. That is W. So 50 men combined, what is the work rate of 50 men? W plus W for 50, that's basically 50 W bricks per day. How many days they worked? Time taken to complete the work is 100 days. So what is the total work? Work rate of 50 men into time taken by 50 men, that's 5000 W bricks is the total work. Now one man, what will be his work rate? 1 W bricks per day. So time taken would be total work by the work rate, 5000 W by W. So he is going to take 5000 days. So 10 men to complete the same work. What about 10 men? Their work rates would be 10 W bricks per day. So their time would be 5000 W is the total work, by they will be putting 10 W bricks in a day. So that will be 500 days. See, there's a simple formula for this, which is basically the same thing. The number of people to do a work into the time taken will be always constant. And this will work when all the people we are mentioning are talking about have the same work rate. So 50 people took 100 days should be same as one person taking T days or 10 people taking T2 days. So T1 will be 5000, T2 will be 5000 by 10, that will be 500, which is what we calculated. A contractor undertakes to build a bridge in 20 days. He employs 10 people for the same. However, after 10 days, he finds that the work is only 33.33% complete. How many more men need to be employed to complete the work in time? So let's assume that one man, right, can put X bricks per day. So basically saying the work rate of a man is X bricks per day. So what will be the work rate of 10 men? 10x bricks per day. So how much work would they have completed in 10 days? Work completed by 10 people or 10 men in 10 days would be, they'll be putting 10x bricks every day. For 10 days they would have put 100x. What is the question saying? He finds that only 33.3% of the total work is complete. So this 100x is basically 33.33%. That's basically 1/3 as a fraction. Otherwise you leave it as even the percentage. So what should be the total work? 1/3 of the total work, or 33.33% of the total work is completed in those 10 days. That is basically 100x. That is, total work must be 300x. Right? Once I know this, once I know the total work is 300x, now what is the left out? Remaining work after 10 days is 200x. Right? The total work is 300x, they have completed 100x, so they have to do only 200x. Now the contractor is trying to complete in the remaining 10 days. They've already spent 10 days, so they're targeted to complete in 20 days. So what is the time left? 10 days. So how many bricks should they put every day? 200x by 10, that is 20x bricks per day. I know that one man can put x bricks per day. So how many people should I need? 20 people, right? For the remaining 10 days. I already have 10 people who are working. So the question asks how many more men need to be employed. So the answer would be 10 more. I need 20 people to work for the last 10 days to complete 200x work, to complete the work on time. But the question is asking how many more men are needed when I already have 10 people who are working. So I just need 10 more people to satisfy the given condition.